Welcome to another exercise for the workbook statistics. This time I'm going to talk about measures of dispersion, and that is for the calculation of measures of dispersion for unclassified data. So our data set and the task here is a random sample of 10 posts of a well-known influencer on Instagram, and the realized likes in thousands are summarized below, giving us those 10 data points. Then we have 4 different tasks to perform. First off, calculate the range of the data set, calculate the interquartile range, the corrected variance, and finally the corrected standard deviation. Well, before we start with either of them, I'm just going to rearrange my data set. So I'm going to take the original data set, and then I'm going to order it in an ascending fashion, so from smallest to largest value. So always taking the next largest value, giving me here in the end this ordered data set. Because working with an ordered data set makes part A and B, the range and the interquartile range, much easier to calculate. Because, well, the range is nothing else than the difference between largest and smallest value. Or if I think about box plots, that's just the height of the box plot. So how much distance is covered from lower to upper whisker. Well, largest and smallest value here in the ordered data set is also last minus first value. So last value minus first value, giving me in the end result a value of 8.6 for the whole range. That was already part A. So we can directly continue with part B, where I'm going to use the same ordered data set. Here it's about the interquartile range. The interquartile range is nothing else than the difference between third and first quartile, or 75th and 25th percentile or quantile. Well, how can I imagine the interquartile range? Again, thinking about box plots, that's actually the height of my box plot. So I'm going to calculate these two quartiles, and I'm going to do this by first multiplying each of those percentages with the number of observations. Here I have 10 observations in general. So 0.75 times 10, 0.25 times 10 gives me 7.5 and 2.5. Then I check whether those two values are integers or not. Here, both of them are not integers. So what I'm going to do, I'm simply going to round them up. And I'm always rounding up. So in this case, I have 7.5 rounded up is 8, 2.5 rounded up is 3. So I'm taking the 8th and the third value. I'm going to use the difference between 8th and third value. So 8.1 minus 3.4, giving me as an end result an interquartile range of 4.7. And that's my end result. That's actually the height of my box plot. That's my interquartile range. I would have to use a slightly different formula if the result here would have been an integer in either of those two cases. But well, in this example, it has not been so. Well, that's already part B. So let's continue with the third part. The third part, we're going to calculate the corrected variance. Here I'm also using the ordered data set, but I could go about part C and D also with an unordered data set. But for range and interquartile range, the ordered data set actually makes much more sense. So for the variance, I first off need the arithmetic mean. The arithmetic mean I can calculate by simply adding up all values and dividing them by the number of observations. So adding up all these values, dividing them by 10, as 10 observations, I'm getting a mean of 5.39. That's the value I'm going to work with. Then for the corrected variance, I'm going to use this formula. That's actually pretty similar to what I did before. Here I use the values as are. Here I'm just going to use all squared values. That's what we can see in this first bracket. That's all the values just squared. Instead of dividing by 10, I'm going to divide by n minus 1. So I'm going to divide by 1 less. I'm going to divide by 9. Then I have to do this correction in the later part. So this is minus. Then I have n divided by n minus 1. And I have to do this correction here and that correction there, because I'm working with the corrected sample variance. If I would work with the uncorrected one, would use n here and would leave this totally there. Well, that was the correction factor here. Then I'm going to multiply this with the arithmetic mean to the power of 2. That's this part. That's here, arithmetic mean to the power of 2. Going to put all of this in my calculator, getting a result for the variance of 8.881. Well, that's, I would say, almost all of the work to be done in this exercise, because now we're only left with the standard deviation. That's part D, the standard deviation. However, we can simply use the variance from the previous slide and get the standard deviation by taking the square root of the variance. So here, the square root of the variance yields us 2.9801, which is our standard deviation, which is our corrected standard deviation. So once I use the corrected variance, I always get the corrected standard deviation. If I were to use the uncorrected variance, I will get the uncorrected standard deviation. Well, that's it about this exercise. So I hope you enjoyed it. I say goodbye and see you next time.